8th grade, we are going to go ahead and do a quick review of scientific notation. Now, this should have been something that you probably went over last year in 7th grade, but you may have forgotten how to do it. This chapter is going to deal with scientific notation a bit, so I thought it would be a good idea to quickly review what it is and how you do it. So, let's take a look at what scientific notation is. It's mainly going to be used for writing very large or small numbers. Okay? An example of this. Let's look at one that might be a very large number. I'm just going to put one, we'll say large numbers in scientific notation. I'm just going to abbreviate that. You don't have to write it out the whole way. So, for example, if I had something like this, 3.86 times 10 to the, 7th. Let's do that. Okay? This is an example of a number that is in scientific notation. In a moment, I'm going to write out what the number would actually look like, but I want to talk about the different components that you see here. So whenever you have scientific notation, it's always made up of two numbers. Okay? This first number always has to be greater than or equal to 1, but it must be less than 10. So greater than or equal to 1 and less than 10. Okay, that is the rule for the first number. If it's smaller than 1 or 10 or bigger, you have to, what we call, adjust it. And I'll show you what I mean in just a moment. The second part of scientific notation is always a power of 10. Okay, it is always a power of 10. And I know that this is a large number because my power of 10 is quite big. Right? It's 7. That's a pretty big number. If I wanted to write this out completely, here's what I would do. I would start with my first number, 3.86. Okay? And I know that every time I multiply by 10, all I'd have to do is move the decimal point over one place. But this time it's 10 to the 7th. So I'm not moving it one place, I'm going to move it 7 places. Move the decimal point, 7 places. So what I'm going to do, I'm going to take the decimal point, and since this is 10 to the 7th power, I'm going to be moving to the right. So 1, 2, 3, 4, 5, 6, and 7. That is the decimal point's new home. Okay? And all of these empty spots here, we fill in with zeros. So that is the actual number, 38,600,000. So these two are equivalent. Now imagine that I had to write out this number in, some sort of report or on my homework or something like that, and I had to write it over and over and over again. I might get tired, writing all those zeros. Maybe I miss a zero and then the entire thing is incorrect. That's why scientific notation is used, because it's very accurate and condensed. Okay, so that is how a large number would look and how you would go from scientific notation to standard form. Now what I'm going to do is show you, let me just adjust a little bit. What if I started with something that was in standard form, but I wanted to write it in scientific notation? Let's say I had, I'm just writing out a bunch of zeros here. How many zeros I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so I've got 10 zeros, 57 followed by 10 zeros. Okay, so I'm going to write this in scientific notation. So here's what you're going to do. You're going to find the decimal point. If you have a number where you can't see the decimal point, assume that it is at the end. Okay? Now, I need to follow my first rule. Remember, my first rule, if I can move this back up a bit, my first rule is that my front number has to be greater than or equal to 1, but it must be less than 10. So I'm going to move my decimal point between my non-zero numbers until I have something that is greater than or equal to 1, but less than 10. So I'm going to start moving it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will have to go 11. I'll have to go in between the 5 and the 7, because if I went only to here, that would be 57. That's too big. If I went one more, it would be 0.57, and that's too small. So right in between, it is greater than or equal to 1. It is less than 10, so I'm good. So this is what the front number is going to look like. And then you want to ask yourself, okay, well, how many times did I have to move over to get my decimal point to its new place? I think I counted 11. Let me double check that. 1, 2, 3, 4, 5, 6, 8, 9, 10. Yes, it was 11. So this is going to be times 10 to the 11th. I know that it has to be a positive 11 because look how large this number is. That's a really, really big number. So this is what my scientific notation would have to look like. Let's try one that's a really small number. Okay? All right, here we go. So let's say I had something like this. Okay. So 6.3 times 10 to the negative 6. This is a small number. Why? Because here's what's really happening. This is really 6.3 times 10, or sorry, 1 over 10 to the 6th. That is what is actually happening. Remember, when you have a negative power, it doesn't mean that the number is negative. It means that it is a fraction. Okay? So 10 to the 6th. Remember, any 10 power would be 1, and this would be followed by 6 zeros. So that would be a very, very, very small fraction. So here's what we're going to do. I'm going to write this out the way it would look as an actual number, not in scientific notation, in standard form. So I write down my first number, which is 6.3. Now, since this is a negative 6, I am this time going to move to the left. All right, so you grab your decimal point, and I'm going to move 6 spaces to the left. 1, 2, 3, 4, 5, and 6. There's its new home. Everything else gets a 0. All right, look how small that is. I'm going to put one more in front of the decimal point as well. Look how small that number is. This is the tenths, hundredths, thousandths, 10,000s, 100,000s, millions, 10 millionths place. So this is 63 10 millionths. That is a tiny, tiny number. All right, very, very small. Now let's say we wanted to, we'll call that A. We'll call this B. Let's say we wanted to go the other way. Let's say we started with something that was a small number and we wanted to write it in scientific notation. So let's say we had this. Okay. Let's say we had that number. So what I got an email. What we want to do is first get our decimal point next to our first non-zero number. My first non-zero number is all the way over here. It's 2. So I need to move my decimal point and get over to 2. So I got 1, 2, 3, 4, 5, 6, and 7. Okay. That is where I'm going to stop. If I went right here, it would be too small. It would be 0.2093, and that is not greater than or equal to 1. If I went any more, it would be bigger than 10. So between this 2 and this 0 is where I'm going to stop. So this is going to be my first number. Okay, and I think we did 1, 2, 3, 4, 5, 6, 7. We jumped over 7 spaces. But remember, this is a very, very tiny number. All right, so this is going to be -7. Okay, if you have a very, very, very small number, it's going to be a negative exponent. If you have a very, very, very large number, it's going to be a positive exponent. Now, there is one thing I want to do. I want to show you in case you ever need to adjust. And here's what I mean. Sometimes, and we're going to get into this in the next couple sections, where you need to adjust your scientific notation. When you multiply or divide scientific notation, sometimes your front number doesn't obey the rules anymore. So let's say I had something like this. I got an answer like this. Okay? All right. I need to fix this because if you notice, my front number is not greater than or equal to 1, and it is definitely, well, actually it is greater than or equal to 1, but it is bigger than 10, which is against the rules. I have to make sure that this number is between 1 and 10. So what I'm going to do, what I would have to do for this one, if I moved this decimal point over so that it is in between the 6 and the 8, well, now it obeys the rules. It is greater than or equal to 1, but it is less than 10, so we're good. But that means I need to fix my exponent because since this guy moved over, now he kind of has to compensate because what did we do? We made this go down almost by 10. So this guy is going to pop up 1. Okay? Because if I were to write both of these out, I'll show you that they are equivalent. So we got 6, 8.3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All of these get filled in with zeros. If I wrote this out, 6.83, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And fill all these guys in with zeros. So after this, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, they are equivalent. So if you have to move this guy over, if he's too big and you have to make him smaller, then your exponent kind of has to compensate for him. Now, if you're doing, let's say you're going the other way. Let's say I had something that was too small. 0.75 times 10 to the 5th. Okay? This time, my first number is too tiny. All right, remember, it's got to be greater than or equal to 1, but still less than 10. So what I'm going to do is take him and move him in between the 7 and the 5. All right? Now he follows the rules. Greater than or equal to 1, but less than 10. Since he had to become bigger, now my exponent has to compensate and become smaller. Okay, and let me show you that these two things are equivalent. All right, whoops, wait. Oh, I wrote that over too far. I was thinking negative. Hold on, let me move this over here. Okay, there we go. So I'm going to move this over 5 spaces. 1, 2, 3, 4, 5. So that's 75,000. 7.5. 1, 2, 3, 4. Yep, also 75,000. Okay? So if you need to adjust your front number and you're not sure exactly what should my exponent look like? What should my power of 10 look like? You can always write it out and then put it into the correct scientific notation. For example, if I had written this out with, all those zeros and then counted over to the correct place, it would get me exactly where I wanted to go. So if you're ever confused, just write it out the long way and then, write it in the correct form of scientific notation. Alright, so that was a quick review of scientific notation. If you need any additional help with it, just let me know.